If x plus 202 is equal to 2001, then what is x? So we have x plus 2002 is equal to 2001. So just do the algebra. So 2001 minus 2002, and that would be -1. So that is a. Which number is 50% greater than x? Okay, well, 50% greater would be 1.5 of x. So that pretty much, that's all there is. Like, for example, if x was 100, then 1.5 times x would be 150, right? And 150 is 50% greater than 100. So that's all that is. I watched 100 ants build an ant hill in 5 hours. Working at the same rate, 2,500 ants could have built the ant hill in how many hours? Okay, so 2,500 ants, and then you're comparing it to 1,000 ants, so it's 2.5 times the number of ants. So that means that the 5 hours, you would have to divide that by that 2.5 to get the number of hours, and that's 2. So basically 2 hours is the answer, and that would be B for number 3. If n is the number of primes less than 50, then question mark is the number of primes less than 60. So all we really need to do is count the number of primes from 51 to 59 and then add it to n. So that's all we're going to do. So let's see here, which one of these are prime? Well, one thing is for sure, that all the even ones you can cross out, because those are not primes, they're divisible by 2. 51, well, actually we have to include 50 also, but that's even, so that gets crossed out. 51 is divisible by 17, so that's not a prime. 53, I believe, is a prime. 55 is divisible by 5, so that's not a prime. 57 is a, no, 57 is divisible by 19, so that's not a prime, and 59 is a prime. So there's only 2 additional prime numbers, so it would be n plus those 2 additional. So n plus 2, so that's B. If the average of x, y, and z is 18, then x plus y plus z is. So x plus y plus z divided by 3 is 18. So x plus y plus z, just that, would be 18 times 3 if you cross multiply. And that, of course, is 54. So number 5, the answer is D. The result of adding a number to itself usually is unequal to the result of multiplying the number by itself. For how many different numbers are these results equal? So what they're saying is you take a number and you add it to itself. So if the number is a, it would be a plus a. And they're saying that usually it's unequal to multiplying it by itself. So these two are not equal. But then they're saying for what numbers is it equal? Okay, so this is the algebra. So that would be 2a is equal to a squared. If we put everything on one side, it would be a squared minus 2a is equal to 0. Factor out the a, and we get a times a minus 2. So therefore, a is equal to either 0 or 2. So that's 2 numbers. So the answer is 2, and that is C for number 6. X plus 1 squared minus x minus 1 squared. Well, I guess we'll just expand it. X squared plus 2x plus 1, and then minus from that x squared minus 2x plus 1. And then when we do this, with the x squareds cancel, it becomes 4x, and the 1's cancel. So 4x is the answer, and that would be C. Square root of 4 plus the square root of x is 16. So square root of 4 plus the square root of x is equal to the square root of 16. So that's 2 plus the square root of x, and that's 4. So the square root of x would be 2, and then square both sides, and that gives you x is equal to 4. So number 8, the answer is B. The side lengths of a quadrilateral Q are consecutive integers. If Q's perimeter is 8, 0, 1, 4, how long is Q's longest side? So we have some quadrilateral, I don't know what it looks like. and the consecutive integers, so x, x plus 1, x plus 2, and x plus 3, okay? So the perimeter obviously would be the sum of those four, so that would be 4x plus 6, right? And they're saying that is equal to 8014. So that means 4x is equal to 8008, and therefore x is equal to 2002. Now, they want the longest side, so the longest side would be this guy, x plus 3. So x plus 3 is obviously 2005. So number 9, the answer is D. The square roots of Pat's and Lee's ages have a sum of 7 and a difference of 1 if Pat is older than Lee. How old is Pat? So the square root of Pat's age and the square root of Lee's age have a sum of 7. All right. And then the difference, I'm assuming, of the square roots is 1. So I think that's the math. If I add these two, I get 2 root p. The l's cancel, and then I get 8. And the root p would be 4, and then if I square both sides, I'll get p equal to 16. And that's what they wanted. So therefore, number 10, the answer is D. If x minus 1 times x minus 2 is 6, then 1 minus x times 2 minus x is equal to x minus 1 times x minus 2. Okay, well, if I insert a negative 1 here, and then I insert a negative 1 here, I really haven't changed anything, right? Because negative 1 times negative 1 is just 1. So I can do that. Well, watch what happens there. That becomes 1 minus x, and these two become 2 minus x. And this side is 6. And that's what this is. 1 minus x, 2 minus x, so that's equal to 6. And that's all that is. So 11 is C. A straight line through the origin in AB also passes through. Okay, so do we have to get the equation of the line? Y equals mx plus b. Our 2 points are 0, 0, the origin, and then AB. So m is rise over run, so that's going to be b over a. And sub that into here. And then we'll put in this guy to get the value for this b. Actually, I should probably use a large b to denote that it's different than this b. So if you put in that 0, 0, that becomes b is the large b is equal to 0. So that basically means that the equation is b over a x. So then they're saying which of those 4 satisfies this equation. And with a little bit of experimentation, you should be able to see that the only one that satisfies it is this guy. If you put in negative a for x, you'll get negative b for y. So number 12 is C. What is the product of all the even numbers that are both greater than negative 10 and less than positive 10? So let's list them. The even numbers. So minus 8, minus 6, minus 4, minus 2, 0, 2, 4, 6, 8. Now if I take all these numbers and multiply them together, what is the product going to be? Well, since there's a 0 in there, the product will be 0. And 0 is even, by the way, those of you who don't know. So that would mean 13 is D. If a line whose x and y intercepts are equal does not pass through the origin, then its slope must be. All right, let's see. Let's draw a little graph here. And they're saying you have a line whose x and y intercepts are equal. So let's say the x-intercept is 1, the y-intercept is 1. So then that line would be like this, right? So I can immediately tell you that that line has a negative slope, but let's just figure out the slope. The 2 points are 1, 0, and 0, 1. So the slope would be rise over run. So it would be 1 minus 0 over 0 minus 1, and that is negative 1. So in both ways, by inspection and by calculation, we figured out that it's C, which is negative 1. The least common multiple of 4x to the power of 4 and 6x to the power of 6. LCM, least common multiple. For LCM questions, you think biggest. I know that may seem a bit contradictory, that for least common multiple, you're thinking biggest, but let me explain what that means. First thing you will have to do is break it up into its prime factor. So this is 2 to the power of 2, and then x, I have no idea. We don't know if x is prime or not, but then we just have to live with that. So 2 and 3 for that 6, and then x to the power 6. Then what you do, think biggest. So for each prime number, choose the biggest. So the first prime number that we have to deal with is 2. The biggest one of these, is it 2 to the power of 1 or 2 to the power of 2? It's the 2 to the power of 2. So that's what goes there. The next prime number we're dealing with is 3. Where here there is no 3, but here we have a 3 to the power of 1, so that's obviously the biggest. And then we have these x's, and I have no idea what x is, but the largest of those 2 obviously is x to the power of 6. And that's it. That is the LCM. So if we actually multiplied this out, this would be 4 times 3, so it's 12x to the power of 6. 12x to the power of 6 is B for number 15. All right, so we got pi times pi squared plus pi, and then we have pi times pi squared minus pi. There's a couple of ways of doing this. You can factor, or you can multiply it all out, and whatever you want to do. I factored it. For example, I factored out the pi, and then I had pi squared plus pi squared minus pi. And then these pi's cancel, and then you're just left with pi times 2 pi squared, and then that's 2 pi to the power of 3. So 2 pi to the power of 3, and that would be C. If the roots of ax squared plus bx plus c are 6 and 9, then the roots of 3ax squared plus 3bx plus 3c are equals 0 are. Well, if this equation has roots 6 and 9, so if we factor it, it would be like this. Okay, and I have no idea what is a, b, and c, but that's how you'd factor it. Then they're saying that you're taking this one. Well, this one, if I look at this, I can clearly see that I can factor out a 3. So let's factor out that 3. ax squared plus bx plus c. Well, ax squared plus bx plus c is right here, and that's this guy. So that means that this is the equivalent of 3 times x minus 6 times x minus 9. And this equation has the same roots, 6 and 9. So there you go, 17 is B. What percentage of 0.5p is p? Okay, so it's like saying what percentage of 50 is 100. So what you would do, you take the 100 and divide by 50 and figure out that percentage. Well, this is 2, which is the equivalent of 200%. So the same thing. If you're sticking some p's in there, it's the same kind of process. You take the p divided by 0.5p, and that would give you 2. Well, because the p's cancel, it'd be 1 over 0.5, which is 2, and that's 200%. So either way, 200% is the answer, and 18 therefore would be D. Exactly how many different pairs of integers represent points on the circle x squared plus y squared is 25? So they're asking us to find integer solutions, and there's quite a few of them. 5, 0 would give you it, 0, 5, 3, 4, 4, 3. And then all the negatives, negatives 5, 0, 0, negative 5, 3, negative 4, negative 3, 4, 4, negative 3, negative 4, 3, negative 3, negative 4, and negative 4, negative 3. So as you can see, quite a few, and that's 12. So the answer is A for number 19. If 17.6x all to the power of 3 is equal to 7883, then 1.76x all cubed is. Well, there's several ways of doing this. You can do it manually with your calculator. Let's see here. 17x all cubed is 7883, sorry. So the first thing is just let's get rid of that cube. So we'll put that 7883 all to the 1/3. And then we want to change it to this guy, right? So what we need to do is divide by 10. Because if we do, then it'll become 1.76x. Yeah. And then we're almost there. We now need to raise it to the 3rd power. So then we'll raise it to the third power. And then that will basically give you what is here. But this side becomes 7883 over 1000. And then that would obviously be 7.883. So that would be C for number 20. For how many different positive integers n will n plus 2, and n plus 4 represent 3 different prime numbers? Let's write the first few prime numbers, and let's see what we get. It's 2, 3, 5, 7, and then what, 11, 13, 17, 19, and so on, right? So we have been asked to find 3 that are differing by 2, and I don't think that ever happens except these 3. I don't think it ever happens again, where you have 3 prime numbers that are exactly 2 greater than each other. So that only happens when n equals 3, so therefore, since it only happens once, the answer would be B. 21 is B. The reciprocal of 4 equals the average of the reciprocals of 3 and, all right, so the reciprocal of 4 is equal to the average of the reciprocal of 3 plus the average of the reciprocal of some number. So that is the, I have to divide by 2, it's the average. It's not just the sum. So first I got to make sure I did the algebra properly, and I think I did. Okay, let's go with this. So cross multiply, you get 2 over 4, and then we get 1 over 3 plus 1 over x. And then 2 over 4 is 1/2, so that's going to be 1/2 minus 1/3 if you isolate for the x. 1/2 minus 1/3, I know that's 1 over 6, and therefore x would be 6. So 6 is the answer, number 22, therefore is B. When each letter in the phrase "my huge taco" is replaced by a different digit, the value of my MYHUGETACO will be. All right, so, well, this question, you might think, well, how am I supposed to know? But here's the thing. A different digit. So the digits are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there's 10 digits. Now, if there's 10 letters, then I should be set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's what I thought. Otherwise, I would have no clue. So it doesn't matter what order you place these digits in. The sum, or they're calling it value, but obviously there's addition signs everywhere, right? Addition, all that. So it's the sum. The sum will be the sum of these 10 numbers, and that sum, I'm sure you could figure out very quickly, is 45. So that is pretty much the approach there. If x is greater than or equal to 100, then x plus 16 square root is between. Okay, let's use a value. It makes it a little bit easier. If x is greater than or equal to 100, let's just call x 100 and see what happens. Therefore, this x plus 16 would be 100 plus 16. And you can use your calculator to figure out that that is approximately 10 point something, 10.7. Now, of the answer choices, where does 10.7 lie? Well, it looks to me like it would be between, root x's would be 10, right? And then root x plus 1 would be 11. So it would be between 10 and 11. So which one is root x and root x plus 1? For number 24, that would be 8. One over 1 times 2, 1 over 2 times 3, and so on, all the way up to 1 over 2001 times 2002. Okay. Well, a little challenging, but here's the algebra. The first one, which is 1 over 2, you can write as 1 minus a half. Okay. Then we add the second one. The second term, which is the same as 1 over 6. 1 over 6, you can write as 1 over half minus 1 over 3. The third one, which is the equivalent of 1 over 12, you can write as 1 over 3 minus 1 over 4. And I think you're getting the pattern here. And then so on. And then eventually, you will get to the last one, which can be written as 1 over 2001 minus 1 over 2002. Now watch what happens. This guy cancels with that. This minus 1/3 cancels with that. And then eventually it will all cancel all the way down to that guy. So then the only two terms that will be remaining are this first 1 and the very last 1 over 2002. And then when you do that math, you'll get 2001 over 2002, which is answer choice C. Add all 100 roots of. Okay, so the roots, let's see here. Let's list them. That's -1. That's 2. That's -3. And so on, right? The next one is most likely following the same pattern. It would be x minus 4 would be 4. And then so on. And then all the way at the end, these ones, the last one would be 100. And this one would be minus 99. Then 198. And then the one before minus 97, and so on. So let's add these. If you add them 2 at a time, that's 1. That's 1. And so on. That would be 1, and that would be 1. So since there's 100 numbers, there'd be 50 pairs, and each pair has a value of 1. So 50 times 1, and that's 50. So number 26, the answer would be B. If the absolute value of x is equal to -1, then it is always true that the absolute value of y is. Okay, there's several ways of doing this. You can either do it just with x's and y's, or you can do it with a number. So I like doing it with numbers. It just makes it, so I'm going to let x equal 5. That means the absolute value of x is the absolute value of 5, which is 5. And they're saying that's equal to -y. So therefore, y would be -5. And therefore, what they're asking, the absolute value would be the absolute value of -5, which is 5. Okay. So if x is something, the absolute value of that is the same. So I have, solved it for just x equals 5, but I have to also do it for x equals -5 and see what I get. So here we go. When x is -5, then that means absolute value of x would be absolute value of -5, which is 5 again. And they're saying that is equal to -y. So therefore y is -5. And therefore the absolute value of y would be the absolute value of -5, which is 5. You'll notice that in both of these scenarios, x is different, but y is the same. And therefore the absolute value of y is also the same. And in terms of letters, it would be the same as -y for both scenarios. So of all the answer choices, the only one that works always is, and they've even put that word in, is D. No matter what two integers I choose, their squares cannot differ by. Okay. Well, for this question, we have to use something called parity. Parity means is something odd or even. So if we have two numbers and we want the difference of their squares, the difference of their squares. So if we factor that, we get a minus b times a plus b, right? So we have to look at a and b and see what their parity is. They can be both odd. You can have both even. You can have even and odd. Or you can have odd and even. Right? So then what we need to do is figure out what happens here. So if you have this scenario, you will have, hold on one second. If you have both of them are odd, so for example, I like using numbers, so we have, let's say, 3 and 5, then 3 minus 5 would be even, and then 3 plus 5 would be also even. So you'd have an even times even situation, which is even. For this one, even and even, so let's use, what, 2 and 4? It doesn't really matter what numbers you use, but just to make it easier to understand, I think, that would be even and even, which again is even. Okay, great. How about even and odd? So we can use 4 and 3. So that's going to be odd and odd. And odd times odd would be odd, right? Yeah. And then finally, odd and even. So we can use 3 and 2. So that would be odd and odd again. So then that would be odd. Okay. Well, the difference is either odd or even. That doesn't really help me very much. But one thing is for sure, that this part helps, that it's even times even. Now, if you have an even number, it's of the form 2n. All even numbers are of the form 2n. And this one would be of the form, let's say, 2m. So if you're multiplying two even numbers, it would be of the form 4nm. So that means that this guy has to be a multiple of 4. Yeah, so that is what helps me. So my conclusion is that the number, this difference, has to be either odd or a multiple of 4. Okay, let's see. First of all, which ones are odd? That's odd and that's odd, so those are okay. And which one of these is a multiple of 4? This one is a multiple of 4. So this one, that 2002, is the one that is not possible. So the answer is A. If I run my first 60-kilometer lap at a rate of 25% faster than my usual 12 kilometers per hour, and my second 60-kilometer lap at a rate of x or question mark percent slower than 12 kilometers per hour, then my overall average speed will be my usual speed. So throughout this question, speed is equal to distance over time. That's what we're going to use, that formula. So 2 laps of the track, right? That's going to be 120 kilometers, and at the speed of 12 kilometers per hour. So speed is equal to distance over time. So 12 is equal to 120 over t. So t to me looks like 10 hours. So 10 hours is how much time it would take to run 2 laps at that speed. Now they've given you part of the question. They've given you that the first 60 is run at 25% faster. So 25% faster than 12 is 1.25 times 12, which is 15. So that would mean that the first 60 kilometers, if we use this formula, just rearrange it a little bit, t is equal to d over s. So the t would be d, which is 60 over 15. So t would be 4. So the first 60 kilometers takes 4 hours. Now that total was 10 hours. So that means we've got an addition. We've got to take that 10 hours and subtract that 4, and now we have 6 hours remaining for the next 60 kilometers. So the next 60 kilometers, again, t is equal to d over s. The d is 60, and the speed, well, actually, we're not solving for speed. We're solving for speed, not for t. Because t, we have to have it as 6, and d is 60. So s would be 10. So 10 kilometers per hour is how much we have to do the next 60 kilometers. Then we have to figure out this part. 10 compared to 12. 10 kilometers per hour. Well, it's 2 less than 12. So it would be, we're basically saying 12 times what is equal to 10. And that means x is equal to 5 over 6. So it's 1/6 slower. And 1 over 6 in terms of a percentage is 16.6%. So that would be the equivalent of A. They actually haven't given it as a percentage or as a 16.6, 50 over 3, which is the same thing. And finally, to get a year's digit product, multiply the year's digits, for example, between 1900 and 2000, the 2 years, 1913 and 1931, each have a digit product of 27. What is the largest integer n for which n of the years from 1900 to 2000 have the same non-zero digit product? So our numbers our years, I should say, are between 1901 and 1999 inclusive, right? So we are between 1900 and 2000, so 1901 to 1999 inclusive. So that means all of these years begin with 19. So the only thing we really need to worry about is the third and fourth digit. So the 19 is going to be common to all those years. So we have to figure out what these two should be in order for the digit product to be the same. So you have to do a little bit of experimentation. So after some experimentation, you can see that if those two digits are a 1 and a 6, then the digit product, forget about this guy, just look at these two. 6 times 1 would be 6. If I put 6, 1 here, that still would be 6. If I put 2 and 3, that would be 6. And if I put 3 and 2, that would be 6. And that means those years, 1916, 1961, 1923, and 1932, would all have the same digit product. And that would, there's 4 of those, and that's the maximum you can get. You can try other arrangements, but you won't be able to get more than 4. So 4 is the largest integer for which this is possible, and therefore the number 30 is C.